So guys, it's 7:05. Let's start our masterclass webinar. A warm welcome to everyone present in today's masterclass webinar. So we from Emertxe host several webinars. One is course demo webinar and masterclass webinar. So let me brief what is course demo webinar and what is masterclass webinar. Course demo webinar is more towards the people who are interested in our course, who would like to know more about our course, our placement statistics, and the industry trends. Whereas masterclass webinar, we invite several industry experts to share their experience and give a talk on the topic that they are experienced in, guys. And this series is a little special to all of us at Emertxe because this is our alumni speaks season. So our speakers during this season will be who were students at some point of time in Emertxe and who are doing very well in their career as of now. So let's move on to the Emertxe's Masterclass webinar season 3 webinar 2. So moving on to the next slide. So what are we? What is Emertxe basically? So we are an edtech company. We were established in the year 2003. So we are mainly into placement oriented training programs in embedded systems, IoT, and also full stack web development. So during this placement programs, what do we do? And how are the audience benefited from us? How are the students benefited from us? As you see in this slide, we have our training programs for two kind of people. So for the fresh engineering graduates who are graduated from the college and who want to take up the course, who are looking to get placed in the core domain, we help them to get skilled in through our course, and then we give them the placements. We help them through to get placed in their core domain. And there would be other set of people, for example, an ECE student who is graduated from the ECE background but working in an IT sector, but he would love to work in his core domain. So in such cases, they will also come take up course with us, and we will also help them with the training programs. Okay, and as you see this image here, so what is it basically? It's just making a pot, right? Pottery. And isn't it fun always to make a pot, or it's always to have experience the pottery, right? So our training programs are also completely fun. It's not only the theory classes that we train our students on, it's also that they implement whatever they learn, they build several projects. So our training program is completely hands-on session, guys. And moving on to the next slide, we have, when we tell we help our students to get placed, there would be several placement partners, right? Yes, Emertxe has over 1,200 placement company as their our clients. So we have all types of companies, be it MNC, mid-size company, or even a startup in that case. So as you can see in this snapshot, we have Qualcomm, Microchip, Chelsea, NXP, which are all huge MNCs who hire us students, and even Continental. And these are all just the snapshots of the companies who come to our company and hire our students, whereas we have many more in our list. So you can go through this snapshots, and we are very proud to inform that all these companies have given a very good feedback about the students that they have hired from us, that they're doing really well in their career. So if you would like to know more about this, you can visit our website placement page, and there is also a placement calendar. So when we tell that 1,200 companies come to hire our students, we have over 100 plus drives happening in a month, and all these data is updated in our placements page. So you guys can go to our website, have a look around, and these are some more companies. As I told earlier, you people can go to our website and view the placement companies that come to hire our students. And coming to the main topic, why do we host these webinars? What is exactly Masterclass webinar? So as I mentioned earlier, we invite industry experts to give a talk. So basically they're sharing their experience. And as I told, this is our third season. So initially, first season, we invited industry experts, and the season was based on emerging technology trends. Okay, so we invited Dr. C.P. Ravi Kumar, who gave a talk on electric vehicles. We invited Mr. Jiddu Mohan, who gave his experience in AI and machine learning. We invited Hariharan, who gave his who spoke about his experience in Linux, Parameshwar in blockchain. So these people are just coming and sharing their experience. So when we talk about this webinar, it's not a formal webinar where our speakers come in, they give a formal presentation and they exit, right? They're just sharing their experience with us. And while sharing this experience, what is happening is that you guys are getting motivated. So that is exactly what is being represented in this slide. It is M&M, where while mentoring you guys, they're also motivating you. Obviously, when they give the talk about their experience, they're also telling that how they overcame their barriers during their career time. So you can also get motivated through them, like how listening to how all they overcame the barriers and they're doing so good in their career as of now. And moving on to the next slide, where everyone are excited about. Yes, we do have quiz winners, and this is a snapshot of our last masterclass webinar quiz winners. So I would like to tell that this masterclass webinar also we are hosting a quiz. Okay, and to participate in this quiz, you people have to be there till the end of the webinar, where we will announce a coupon code, and this coupon code should be entered. And our quiz will be through Google Forms. So this quiz code will also be validated with whatever quiz code that we announce during this webinar. Okay, so only if the quiz code is correct and verified, you people will be eligible to be one among the winners. And why do we do this? Because we just want people who are attending these webinars to take part in our quiz. Not everyone can take part in this quiz, right? On a Saturday evening, you guys are putting so much efforts and attending this webinar. So guys, let's make a use of it. Attend, please be still end of the webinar, where I will announce the quiz Google form link and the quiz code, so that you guys can enter. And then it's your chance also to be on a social media wall like these guys. And there will also be few questions regarding certificate. Yes, all the attendees and all the participants will definitely get certificate of participation from us. But please note, you should attend the webinar till the end. You can't just attend for 5 minutes and expect the certificate. This certificate is also only for people who are there till the end. So similar to quiz process, our team will be sending out an email regarding these certificates also. On most probably on Monday, you guys will be receiving these certificates. And guys, we have a system in place where we capture everything. So don't think you can escape from this. Please attend the webinar, participate, and we will have this webinar as a live interactive session. And coming to our speaker, we have Pranith Michael as a speaker. Let me introduce our speaker for the day. So Pranith is one of our prestigious alumni student who took up the embedded system course. Pranith is currently working as software developer at Ford in Toronto, Canada. Okay, so he has 9+ years of experience in embedded domain. He's experienced in he's worked in various well-known companies like ByDesign India Private Limited, Cypress Semiconductors, etc. And Pranith holds a bachelorate degree in electrical and electronics engineering, and he further pursued his passion by obtaining master's degree in embedded systems, electronic embedded systems, in one of the well-known universities in France. Post his master degree, though he got a job that was not suiting his passion, everyone has a passion to work in the core domain who are from circuited branch. So that is when he figured out about Emertxe, he joined us and he enrolled for embedded systems course. So his hard work during the course, and how he managed his work, as well as though he was a working professional, he managed his work and also the course. He did amazing in the course. He got placed by Design India, where he achieved his first career breakthrough into this world. So from there was no question of looking back. And his journeys from being a dedicated student to a seasoned professional is a source of inspiration for everyone. Even today at Emertxe, among mentors, his hard work has been one of the talks. So I will be pausing in between. I will hand over the presenter mode to Pranith. He will be presenting now, and please keep your questions coming in, guys. I will be pausing him in between, and I'll be asking all your questions so that he can clarify all your doubts. So let's make this webinar an interactive session. So over to you, Pranith. Hello.
Yes, am I audible?
Yes, Pranith. Hello.
All right. Let me try and just share my screen.
Yes, I'll stop sharing my screen.
Okay, please give me a second.
Sure, sure.
Could you reinitiate the presenter mode again? I do not see an option.
Sure, sure, Pranith.
All right. Just want to check. Okay, I think we are good to go. Is my
Okay.
screen visible?
Yes, yes, your screen is visible.
Okay, thank you so much, Kavya.
You're
So,
welcome.
yeah, so without further ado, I think I'll start. So, good evening, everyone, and I thank everyone for joining in on a Saturday evening. I know it takes some effort to postpone your plans to be present here for this webinar, and so I'll try to make it worthwhile for you guys. I'm very happy that Emertxe has made it possible for students and working professionals to be able to interact this way. And it's good to see so many of you were able to join this webinar. I'm a little overwhelmed because partly because I've not presented in front of a large audience for a long time, but I'm overwhelmed in a good way. So I think, yeah, without any further delays, let's look into starting your career as an embedded engineer. So this is the agenda for today. So over the course of the next hour and a half, we'll be looking at my professional journey. After which we'll look at some aspects and questions that concern starting your career as a embedded or as an Emertxe certified embedded professional. We will look into some of the questions that you might have. I will try and interlace my insights and reflections in between. We'll also discuss some of the essential skills that that you would need to build, and we'll deep dive into problem solving and problem approach, and what exactly we mean by system level thinking. And to finish up, uh, we will look at some pointers on how to thrive in a text landscape. So I'd like to start with a disclaimer and a quote, if you may. So, one thing that I'd like to say is that all opinions and views are from my personal experiences. You may come across some puns and silly quips during the duration of this presentation, so kindly bear with me. I am not endorsed by Emertxe in any way or form, but on the contrary, I do not turn down any opportunity to endorse them, as I'm very grateful to what they provided to me, just as some of you are. And this is in line with the old adage which says, give a man a fish and you feed him for a day, teach him how to fish and you feed him for a lifetime. I'm yet to find a vegan equivalent of this proverb, but I hope someday it comes through. All right. So the career path for every individual is different. Uh, I'd like I'd like to take you all through my professional journey and how I got to where I am today. As my mom says, aim for the moon and you'll at least land on top of a tree. Not to say that she doubted my abilities, but this is to say that she wanted me to just keep at it. So um, I started off, I completed my engineering in the year 2012, and I was grateful to my project partner who helped us secure a project internship with the Defense Avionics Research Establishment. And shortly after the completion of my engineering, I was fortunate enough, despite financial challenges, I was fortunate enough to be able to pursue my master's degree abroad. Um, and I completed my master's degree in the year 2014, interning with Renault Trucks Defense, where I worked on the study of indirect effects of lightning. That basically high frequency, high current, and high voltage injected on tactical and light combat vehicles. But when I got back, I saw that I was falling short. There was something amiss. I had a theory, but I somehow lacked the practical know-how. I realized that I needed to train myself, and I knew that it was a journey that I could not take up on my own. And this is where Emertxe really helped me bridge the gap. And they helped me find and secure a job in Velankani Electronics Private Limited, which was also known as By Design at that point of time, where I started off my career as an embedded software engineer, followed by my career as a firmware engineer with Ati Motors. This, I would say, is the most pivotal point in my career. This I really relish and cherish the time that I have spent here at Ati Motors. It helped me form into an embedded engineer, and also helped me in various other aspects of being an engineer. Shortly after this, I moved into Cypress Semiconductors, which later was acquired by Infineon Semiconductor Technologies. And I joined in as a staff applications engineer in the year 2020. Um, and then I joined Ford Motors Canada as a software developer, and that's where I am today. So let me give you a quick history of the beginning of my uh, professional journey with Velankani Electronics Private Limited. So Velankani Electronics Private Limited was a mid-size organization. I would say close to about 900 employees. It is located in Electronic City, Bangalore. I started off as an embedded firmware engineer here. And at that point of time, VPL was working on very niche products in the Indian market. And that's where I got to work on a product which was the first of its kind in India. And that product was an off-grid energy storage solution, similar to what we have at Tesla. So Tesla uses something called as a power wall in order to power up homes, with the exception that it is an on-grid storage solution wherein it would contribute excess power back to the grid. So what I mean by off-grid power solution is when we have a battery storage solution to power up a home which charges itself through either solar or the electricity grid, and then once it is charged, it will be able to support the power needs of a home during peak hours. So I worked here on intelligent battery management systems. I worked on different battery management technologies such as active and passive balancing, and I also was able to take part in to conduct extensive research from the product conceptualization to board bring ups for multiple controller boards that we used in this solution. So this was a 7 kilowatt hour solution. It was designed to support the electricity needs for homes and offices. It was a scalable solution, which could be scaled up to about 100 kilowatt hours, from 10 to 100 kilowatt hours to support data warehouses. And we developed in-house battery monitoring and balancing boards based out of LTC chips. If I remember correctly, it was LTC 3300 and 6804. And the reason why I know these ICs by name is because of the time that I've spent trying to bring up the interface communication between those ICs. So this is what a prototype looks like when you work for mid-size organizations and startups, basically. So you get to see the piece-wise integration of your entire product and come together in order to become your prototype. So you take it from the ideation to a point in time where it's ready for production. So you get to experience this and witness this when you are a part of such organizations. Here you can see that you have an enclosure which houses the battery modules. These battery modules were made up of lithium-ion cells, similar to what you have in the Tesla cars, with the exception that they were 18650 form factor cells. You have about 6 modules that you see here. Each module consisted of 2 battery packs in which cells were connected in series, and the 12 packs that you see manifested as 6 modules were connected in series. So this would have this would have a total of 90 about 98 volts. We had some cooling systems which were developed or integrated into this prototype. Here you can see some fans towards the left. And when you are involved in prototyping, you see different aspects of your product in a practical implementation scale, and so you end up coming to know what are the things that you need to put together in order to make it operational. Towards the left hand side, you can see a red color board. This was the battery balancing and monitoring board that we worked on and that we helped develop. And I was responsible to bring up these boards to establish communication interfaces to implement the balancing algorithms that you see here. We were a team of 2 2 people in the software and 3 in hardware. And this intelligent battery management system also had a motherboard that you see on the right hand side of the slide, the green board. So this would help us in data logging and then making sure that we are meeting the safety critical aspects of operating this battery module and battery pack. And we were finally able to power up some load in order to demonstrate the capability of this product. And one thing that I'd like to mention here is battery management systems are a very niche technology that you can look into in your spare time to get some more idea into how this is done, because it's used everywhere, almost on all devices, and the battery balancing and monitoring algorithms keep continuing to develop owing to the um, advancements in the chemical structure and the capacity of the lithium-ion cells. Shortly after this, I joined the most exciting part of my career, and that was Ati Motors. So, in Ati Motors, we developed a three-wheeled electric autonomous cargo vehicle, which was intended to aid material movement in warehouses and manufacturing units. So, this was a completely autonomous vehicle. Here you can see some of our prototypes in action. This was a mature prototype. What you see here was named P2 because it was literally the second version of our prototype. The electric vehicles make use of lidar, cameras, ultrasonic sensors, so on and so forth, in order to implement a navigation or autonomous stack. So what the vehicle would do is use these lidars in order to simultaneously map and localize itself in different environments. There were object detection, collision avoidance algorithms, as well as motion path planning and motion tracking, motion control, which was utilized in these vehicles. I worked on the navigation side of this autonomous vehicle, where we would control the different motion aspects and the powertrain of these vehicles. So this is what we experienced working here. Here you see the first mock-up prototype that was simulated on software of what we wanted the prototype to look like. This was the first prototype, and I remember the first time we ran this prototype. It was in the middle of the night at around 3:30 in the morning, where we were able to get this running, and we had integrated everything that the vehicle needed to have in order to navigate autonomously. So in startups, you see designs and ideas come to life. And this is a very enriching experience for anybody who's starting their career, to be involved in this sort of a development cycle, where you get to interact not only with your team, but cross-functionally across team, with hardware, with procurement, and you get opportunity to go beyond your role. And one thing that I was able to achieve here was to interact with the suppliers and vendors and try to understand what are the different types of sensors. We would benchmark them, we would see what would be a right fit for us, and then we would finally end up integrating. So the one you see here on the right hand side is a mock-up of what the vehicle would look like once we had the fiber casting done. And here, the bottom left, you see how it actually looked once we had all of this assembled. And we used to test our prototype in Indian Institute of Science. You can see here a video of how we are able to navigate through one of the parking lots of Indian Institute of Science, and I really cherish these moments where we all came together as team, both the autonomy stack as well as the hardware and electronics team, to even see this our labor just move around autonomously. So this was a great experience. A funny story is how I was interviewed for this startup. So I remember moving in, being called for an interview here. And when I showed up for an interview, I saw the two founders, Dr. Vishwanath and Vinay, and Mr. Saurabh Chandra, and another probably one of the kid of probably one of the founders. So there was a young man or a young boy, I would say. He was about 15 years old at that time, and I felt it was a little disrespectful at first because we had children sitting for a technical interview. But little did I know that he was one of the founders of the company, and that's a great part of working in a startup where you come across such prodigies. The name of this prodigy was Saad Nasir. He was 15 years old at that time when I joined, and he was one of the founders of this company. In fact, most of the navigation and autonomy stack was optimized and was written by him. So during the development of this prototype, I got to dabble with a ton of sensors which I on my own would have never been able to acquire, test, or even spend time on. And these treasure trove of sensors was made available for me, and this is what we primarily used in order to bring up the motion control for the device. So I was extensively involved in the ground up development of this autonomous cargo vehicle that we named as Sherpa. And I worked on the system architecture, the design and development of the battery management system, and this is where I leveraged my previous experience working on BMS to what we would then later try and implement on our autonomous vehicle. I also modeled lithium-ion cells for different different capacities, different chemistries, and different power densities, and we would try to simulate them to try and understand how these battery packs would behave once we had them integrated in real time, so that we could decide policies and operating conditions which would be ideal and suitable for the complete operation of the battery pack. So they were gauging approximations and the different algorithms that I had to work on in order to even before I got to put my hands on a real lithium-ion cell. I worked on sensor integration and programming different drivers for different sensors. You can see as I've put up, these are some of the sensors that I was able to get my hands on and which went onto the vehicle. We had rotary encoders, absolute encoders. We had military grade IMU for actual measurement. I worked on BLDC motors, integrating and the control of BLDC motors, DC motors. I also got to have my hands on ultrasonic sensors, 3 gigahertz radar that we had integrated onto the vehicle, linear actuators, stereoscopic cameras like IntelliSense, and a bunch of lidars. So the lidars are basically what help these autonomous vehicles look beyond what meets the eye, and that's how they are able to get a sense of what lies around them. Here you can see the 3 founders on the top left. The one in the blue shirt is Mr. Saurabh Chandra, followed by Dr. Professor Vishwanathan Vinay, and then you see Saad with our first prototype P0 that we had in our lab. Our office was above a supermarket in Malleshwaram. Anybody who would pass by would not have been able to guess that we were working on India's first autonomous cargo vehicle, 3-wheel cargo vehicle. You can see the P1 or the first, that was the P0, what you see here with the founders. What we named as P1 is what you see on the top right corner, which is being deployed, which was deployed in a manufacturing unit. So these autonomous vehicles would tug pallets across large manufacturing units, where it would be very tiresome to have people move heavy objects in and around the manufacturing units, which are literally acres worth occupy acres worth in space. The bottom right corner is where you see us assembling the P1. This was in the middle of the night, where we got the vehicle assembled. So I was involved right from the assembly even to the routing of the cables in this vehicle, and I had to plan and design where each and every component would be mounted, along with the other stuff that I used to do. So it was a very exciting time. And today, of course, because it was a scalable architecture, you see different variants of the autonomous vehicle deployed. So we had, they have named them as Sherpa Tug and Sherpa Light, and all of these are today deployed in huge manufacturing facilities. So this is the part where working for a startup actually brings into perspective the complete product development life cycle. So we started off in the labs where we would have just nuts and bolts. It was completely empty, and within the end of the first year, we had our prototype P0, and within the end of the second year, we had our prototype P2, which you see here on top. And that's what makes working for a startup great. And today we have different variants of these vehicles which are different, which are deployed for different purposes. After my work at Ati Motors, I joined Cypress Semiconductors, which later got acquired by Infineon Technologies. This was in the year 2020, and here you see a pic of where Cypress Semiconductors was located in Bagmani Tech Park. And today you would see that Infineon, it's Infineon which has acquired this building and conducting its operations there. So I joined as an application engineer here to work on automotive controllers. Automotive controllers. And one of the automotive controllers that Cypress had at that point of time was the Travio 2. The Travio 2 series is what is used in body control modules as well as cluster graphic control that goes into different cars by automotive vendors. So I worked on the variant of all variants of Travio 2, especially the graphics side of it. So Travio 2 automotive controllers were basically multi-core controllers, and as a part of my job, I provided application support to OEMs, distributors, product design houses, and also helped in resolving some issues pertaining to the low-level MCAL configurations. I worked cross-functionally with IP design and product categorization teams in order to derive workarounds for complex issues that the OEMs would report. And I also, a part of my job was to be involved in answering technical queries in the Cypress, but now Infineon developer community. Um, we contributed to product specific documentation, FAQs, and knowledge based articles. And this was a point in time where I merged my interests and my hobbies into what I was doing. A side hobby of mine is making short films and video editing, and there I put that to use here, where I proposed video-based knowledge-based articles, and I try to drive the initiative to script, edit, and produce technical videos for Travio 2 controllers of how we could set up the device, um, um, set up different drivers and examples, and then utilize the features of what Travio 2 had. So you can always visit the Infineon developer community. It looks something like what you see on the left-hand side, the left top corner of this presentation, where you can pose questions related to their products. It might be design and integration issues that you might face. It might be general queries. It might be clarification on what you see on the data sheets of these devices that they offer. And all of these are answered by application engineers. The application engineers also help come up with the hardware abstraction libraries and code examples that comes along with the driver libraries that you can download for their different devices. Here you can see a snapshot of the sample driver library that comes along with the Travio 2 microcontrollers. We also help in resolving issues that OEMs and automotive vendors come up with. So we would have live debugging sessions with them to step through our code, to step through their code, to understand where they're facing issues and in order to resolve the issue that they have. And as a result, I got to work with different automotive debuggers and tool chains. This was a value add for me. During the course of my employment here, we wanted to understand what it is to have a system level thinking. And that's where the entire concept turned up, and I began to see how information and how subsystems are pieced together. Because I had experienced this in a startup where we saw all of these subsystems come together, and now I had gone to the lower level where I was completely working with the microcontroller manufacturing industry. So I moved from not only seeing the implementation of the microcontroller on the field, but also how the microcontroller itself is manufactured and how we provide support for that basic automotive microcontroller. And there was a strong initiative within the company to try and understand what a system level approach would look like. And so I rolled off an initiative to have a small project between the teams where people from different teams could collaborate to work on a simple two-wheeled balancing robot using components that Infineon already manufactured. We would integrate these different components onto the robot, and then implement necessary control logic algorithms in order to have the robot and get it to balance. So this was an interesting project, especially for the people around me who kind of saw what the practical application of the microcontrollers that they support would actually look like. After working for Infineon, I had the opportunity to move abroad and start my work with Ford, where I work as a software developer on the AUTOSAR side of things, on the next generation electric platform that Ford has to offer. So typically where my role would fit in is on the model-based development side of things. An AUTOSAR is actually an ecosystem. And what we need to understand is there are multiple teams, teams which describe the technical specifications and requirements and feature definitions. And then finally, it would move on to developers who would try and either hand code or come up with model-based design in order to generate code that is later integrated onto the extract that goes into your final ECU. So on a vehicle, you have multiple ECUs, high performance clusters, zonal ECUs, which are constantly communicating with each other. And most of the times, these are safety critical applications. There may be active and passive features that get integrated onto a car. And that's how all of this information comes together in order to get your features in your car working. And this is where I work. I work in the model-based application development for automotive features. I'm involved with the design, simulation, testing, code generation, and integration of software with the base software. What we do in model-based development is we develop automotive features, and these automotive features are something that you guys would at least would have heard of. We have a ton of sensors on the car. We have different warnings, chimes, reconfigurable telltales that you see on your infotainment cluster. Uh, you see a lot of sensor integration that happens in order to get a feature to work. So even let's say a basic feature like a telltale for a low washer fluid or a battery charge, a battery low charge that you see once you turn on your car, are features. And these features are implemented through body control modules and gateways that help all of these ECUs communicate and communicate with each other. You have different inputs coming in from different parts of the vehicle, and you have a business, you have one gateway which implements the business logic in order to manifest this feature on a car. So now that I have tooted about my experience, I would now try and focus on you, and we will discuss what it means to start your career as an Emertxe certified embedded professional. And before I talk about this, I want to kind of rewind the clock and get you to time travel into the time when I was an ECEP. And then I had to make decisions of what I wanted to do and where I wanted to progress my career. I had a lot of questions which were unanswered, and I really thank Emertxe for providing this platform where where alumni can interact with you, and you are given the opportunity to kind of understand and interact with them, try to understand the challenges that they faced, and have your questions answered. And I've put together a list of questions that I had, which probably you have also, and I can empathize with most of you. For those of you who are working, it's well and good, but for those who are looking to start their career, these are some of the questions that you might have, and I've tried to answer a few of them. So we usually start off once we have the experience that we have and the technical skills that we've acquired at Emertxe. We begin to ask these questions, right? Must I join a startup or an MNC? Should I get into IoT, automotive, networking, or should I dabble with AI? Is this really my cup of tea? Am I meant for this domain? What if I'm unable to clear the interviews? What if I get stuck on a problem that I'm not able to solve? How do I even begin to understand large code bases, frameworks, and software stacks? Are there any best practices I can follow? What other technologies must I learn? And how I can keep myself motivated? So these are some of the questions that I believe that most of you would have, because these are the questions that I had once I had acquired the skill set. Because you are geared up, you are excited, you know all the concepts of programming, and you now feel like gladiator getting into the ring, ready for a fight. But you come across challenges and hurdles that you need to be mindful of, and um, uh, to be aware of, so that you will be able to overcome those challenges. So let's start to tackle some of these questions. Um, must I join a startup or an MNC? So you saw from my professional experience the pros and cons of probably working for a startup, which I would try and reiterate, and then what you would see in an MNC now that I'm a part of a large MNC. So startups, we build everything from scratch. So you get to witness the birth of a start. You see everything coming together. Whereas in MNCs, we actually build on what is already there, and both offer good learning curves for anybody who's starting their career. Here I've listed out some of the pros and cons that that I have probably through my experience understood about working for a startup and an MNC. So startup is a pretty easy one. You saw that you witnessed the complete product development life cycle in close quarters. You're involved from in the ground up design. There is an attitude of burn and learn, break and make environment. So this challenges the inner engineer in you. I remember we had come up with signal conditioning circuits that we would use in order to validate our design, in order to simulate conditions what would take place on an actual autonomous vehicle without even having built it. So you have more opportunities to innovate. You begin to connect the dots. You're able to map the theory and practical aspects, and everything starts to make sense to you because what you had studied in your engineering with respect to digital signal processing or signal conditioning or linear integrated circuits, and all of these come together with uh, the practical aspects of developing a product. So you get the theory of everything. So everything will begin to make sense, and all the patterns, your mind connects all the patterns. So you dive headfirst into the greatest learning curve of your life. Some of the drawbacks of being in a startup are there are long work hours. You'll have to possibly work on the weekends. But again, this is not necessarily a bad thing because we enjoyed working on weekends and we enjoyed working long hours simply because the product was great. And there's a possibility of a disrupted pay. Again, you see conditions apply there. It's because some of the startups have a hard time in the beginning securing funding. And venture capitalists are basically sharks. They would only play to their benefit. So when a product is in its nascent stages, venture capitalists are usually wary of investing in startups, and over time that changes. You get to a point where your the venture capitalists are basically outbidding each other in order to have a share of the company. But until then, there would be certain period where you would not be paid, uh, where the company has to balance between putting up a prototype and supporting its design costs. And this is again very conditional. It's very subjective. It doesn't happen everywhere. It doesn't happen to everyone. But this is something that you need to keep in mind when you look out for a job, because will help you make some calculated decision. Then you have limited growth opportunities, I would say, because if you are very concerned with your title and you've already worked about 2-3 years in the startup and now you're looking forward to be promoted to a higher title, that is less likely to happen, because in startup the ideas of titles is very ambiguous. Nobody pays much attention to those. But if you are a person who kind of for whom these things matter, then it's something for you to consider. In an MNC, you are part of a well-oiled machine. You have the opportunity to enhance your skill and master it. So everything, the requirements and the deliverables are well defined when you're working for an organization. So this makes it easy to focus your effort. I even in the company that I work for right now, a lot of the requirements of these features were already defined, and it's a matter of implementation. It's a matter of course correction and fault confinement, and trying to get into the safety aspects of it, trying to optimize it, and trying to make few innovative changes wherever possible. But what it goes to say is that you can focus your effort and then master one skill or a bunch of skills, and the MNC environment allows you to do that. And you have the opportunity to branch out into either managerial or technical cadre. This is because MNCs do offer two alternate career paths for you as you grow up in ranks. you can always choose to stay on the technical side, or if you have the managerial streak in you, you can branch out into the managerial aspects of your of jobs that they offer. This is somewhat not possible in a startup. Your efforts are recognized. You receive bonus payouts and insurance. Again, this is something that differs from a startup environment. You do have a bonus, but again, it is subjective to different startups. There are possibilities for on-site opportunities. Not that it matters anymore, and I'll come to why. But if this is something that that really plays on your mind, that you want to be a part of an MNC because it offers on-site opportunities, then yeah, it is something to consider. And there is a conditions apply here, because you may or may not get to go on an on-site opportunity. So again, this is subjective. This is something that you'll need to understand based on where the company is at right now, and the team that you work for. Does it have applications that are parallelly being developed or worked on in different countries? Work can become monotonous as a downside in MNC. You tend to stagnate, because what happens after you've mastered your skill, and what happens after you already have understood whatever there is to understand? Then work becomes okay, manageable, but it becomes monotonous. You do the same thing over and over again, um, and you need to think about whether it's an environment that you'd like to stay, or you would want to grow and get into much challenging roles elsewhere. You have limited exposure to other technologies because you are focusing only on one implementation. Your functional role is already structured into the organization, so you are a functioning block in a larger structure, basically. So you work on your purpose, your role is defined, and you do not get to interact with other teams, or you do not get to witness other technologies. This, I would say, is one of the downsides of working in an MNC. And the downside to both of them is that there is high expectations to deliver within short turnaround times. This is a valid ask for both startups as well as MNCs, but it completely depends on how this is executed, I would say. So, uh, so now you have a plethora of domains that you can work on, and and I would like to say that in the beginning of my career, I was obsessed with automotive. I was infatuated with AutoSAR, and all that I had on my mind was I wanted to get into Bosch. I wanted to get into AutoSAR, and that is something that I didn't want to listen to anyone. I did not even pay attention to IoT. I did not want to get into aerospace. I was very obsessed of getting into an AutoSAR based role. Why? I don't know. But I would say that it was a fad at that particular point in time, where if you're an embedded engineer, then it make complete sense for you to move into an automotive domain. And right now I'm in the AutoSAR automotive domain, but I really miss the startup environment, I would say. Uh, an interesting fact is that um, even though in the beginning of my career I did not move into the AutoSAR domain, I I am grateful for it, because I got to join Ati Motors, because I got to join a startup, and which was into the autonomous robotics application. I remember I had an opportunity to interview with Bosch, and I got rejected. I was very disheartened, but I thank God for that rejection, because if I were to join Bosch, then I would have never got to work on such exciting technology. So then again, it goes to say that don't be stressed out about where you would start to work and begin to work, because if you have a bird's eye view of all of these, your skill set caters to every domain. And this became more evident to me when I started to work for a semiconductor company like Infineon. because they manufacture microcontrollers, ICs, and different components that are used across the board, except for the military grade. But you see all of them being implemented, all of their products being implemented in each of these domains. So I would say don't be stressed about where you get to start your career. Just know that the skill sets that you need to develop is what you need to focus on.
Thank you, Pranith. I would like to interrupt you here. We have few questions coming. So thanks again for giving a clear difference how MNC works and how the learning curve peaks in the startup companies. So we have a question. So what are few of the key responsibilities and tasks that you handle regularly?
Okay, yeah, it's a good question. So as an embedded engineer, right, you are mostly involved in developing code, writing drivers, board bring-ups, verification, validation of the hardware boards that you get. You are sometimes involved in algorithm development, control algorithms that you need to understand and implement. So that is why they ask for a good programming skill set, because you know how to write code, you know how to optimize it, and all that you need to figure out is the logic that you implement it with. And logic is something that that every person needs to work on. It's something that you get to experience in Emertxe through these assignments, where you have to think through, understand. Even before you write code, you'll have to think through the logic and then implement it. And that's how we were taught when I had joined. And that's a skill that has helped me along my career.
Thank you, Pranith. And we have one more question. So they would like to know how you bridged your gap and how Emertxe helped you to land on your domain job, core
Okay.
domain.
Okay, so I think everybody here, at least who has visited the Emertxe website or spoken to somebody at Emertxe, knows what are the different modules that are taught. And you can see these are the quintessential building blocks that you would need to have, right? So you have your embedded C programming, you have your Linux kernel internals, you have your device driver development. Um, you have even your full stack development and a little bit of AI from what I got to know. So you need to focus on these skills, and these skills actually help you bridge the gap, because if you are battle ready, then you are more confident to take on any development challenges that you are posed with.
So we have one more question. What technologies in future they rule in embedded? So how was the progression of embedded systems is what they're trying to ask.
Oh, very good question. So when we talk about future technologies, right? So from where I see is that we have a lot of AI ML creeping into the different aspects uh, uh, of embedded control designs. So you might have you already have your IoT in place, and you have different software stacks which are now coming up, such as TinyML, which can be ported onto a controller, similar to how you would port FreeRTOS onto any controller. You would have TinyML, and then you try to basically run some sort of a data classification engine on your controller in order to be able to handle real-time applications. So that's one aspect of it where AI/ML works. But the core principles always remain the same. So I have seen I've seen automotive, I've seen consumer electronics, I have seen semiconductor technologies and robotics, and all of them make use of motor control. All of them make use of sensor integration. All of them make use of some software set of codes, or I would say implementations which are similar So I would say that the underlying structure which holds the logic of your entire product together is pretty much the same. So there is only something that you can build on top of it. You can optimize it, you can enhance it, you can make some cross connection between the subsystems, but uh, those building blocks will always remain. So that's something that that's something to think about.
Okay, we have one more question from Yashoda. So, what are the mandatory skills to start the career as an embedded engineer?
Good question, Yashoda, and thank you for that question. And we will shortly touch upon.
Okay, so we have another question. So he's a 2023 Triple E passed out student, but due to lockdown, he got distracted. So he's asking, what do I need to learn to enter the job, basic level job in core domain?
Okay. Does he mean, or okay, I assume that he is referring to the embedded domain when he
Yes.
says that. So 2023 pass out is good. It does actually. I would say I would go on a fast stretch and say it doesn't matter which year pass out you are. What matters is whether you're able to clear the interviews and land a job. And for
Mhm.
clearing interviews, you need to have you need to be confident in your skill set. You need to have some a good grasp of your fundamentals in programming, and a few other things that I will talk about. And Mm. and also you need to be uh, uh, a problem. You need to have some sort of a problem solving ability, and that's what most of the recruiters or most of the interviewers tend to look for. And I plan to cover that in today's session as well.
Okay, Pranith, thank you for answering these questions. You can go on with your slide, and I will again ask out few questions in the later part of the presentation. Thank you.
Sure. So so let's continue. So as I said, as our friend was asking, right? How do I get into the domain? So uh, let's tackle this question right now on what would you do or how would you progress further in clearing the first step. So this is your day zero and this is the interview. And from my experience, I've tried to put together here four different aspects that you need to focus on in order for you to be able to clear an interview. So the initial step is your prep work. It's like a level one of what you do. It involves your general preparation and a brush up of your technical skills, your programming skills. You have to try and revise the topics in a logical manner. For example, you can start with the most underlying aspect of a controller, which is booting. Then you can go on into the booting process, the bootloader, and then your application code, your different microcontroller features. Um, so you try and revise and prepare your topics in a logical manner. You even go through your programming, probably your notes in the same logical manner. To be very honest with you, I still carry a copy of C in depth with me. It's like one of those things that you get up in the middle of the night and you search for your engineering degree, whether you really completed your engineering. It's one of those things for me where I carry the textbook with me wherever I go. And today I might be in Canada, but I still have the textbook with me on my shelf. So any interview, any preparation, you'll have to revise logically so that your mind is able to better map the concepts, pointers, structure unions, and bitwise operations, and your stages of compilation. So all of these things you can visit in a logical manner so that uh, uh, it forms a mind map of sorts for you to be able to answer the questions better. Practice examples on pointers, bitwise operations, and structures. This these are aspects where they will check your logic as well as your programming concepts. The second aspect is conceptual understanding. So this is the first level interview preparation that anyone would do, but there is a deeper level that you need to get into. You need to look into software programming concepts. You need to look into a little bit of OS concepts. You need to understand microcontroller features. You need to understand concepts like what is sampling, what are the different types of ADCs, and what is IPC. So have any of you wondered that when you have your cell phones or any other device which are multi-core, quad-core, octa-core environments, you have different cores which are clocked at different frequencies. And how do you think that these cores communicate with each other if they're operating at different speeds? How do they exchange data? How do they pass on messages? So for this, we use interprocessor communication technologies and methodologies. So I would say that you need to try and spend time to understand, a deeper level of what you're getting into, of what features your microcontroller offers, because these are real world applications. So these you would be working in a multi-core environment where you would need to send data from one core to another core in order to perform a safety critical operation. So try and spend time to understand conceptually. You can even refresh your basic electronics so that you are able to better present a design if somebody would ask you for. I remember during my interview at Cypress, and it was a dreaded interview experience for me, because it was the first time in my life I had to give 6 rounds of technical interview with different teams. And that goes to show that even if you have cleared 5 out of the 6 rounds, and you don't clear the last round, you still don't get a job. So you need to have a good grasp of your concept. So one of the problems that was posed to me during the interview was that you have only infrared sensors, okay? And let's say, how do you maintain or keep a count of the people that enter into a meeting room with infrared sensor? And you had to suggest a solution. So you begin to think, you begin to brainstorm, okay, how will I implement this solution? So this is not related to programming, this is not related to basic electronics, but this is related to how you would go about solving a problem that is presented to you. Problems often happen or often arrive in a domain or in a concept that you are unaware of, and that is logic. So logic is where you need to focus on. And for you to be able to logically come up with innovative answers, you need to have a good grasp of your fundamental understanding. So I would say the level 2 is the conceptual understanding of your concepts. Do your due diligence before you go to an interview. You research about the company's product line. You understand the roles and responsibilities that was provided to you as a part of the interview schedule or the LinkedIn page or the posting, right? So why is it necessary for you to understand this? Because once you know what product they are focusing on, you can frame your answers in line with that product. So for example, a very crude example I would say is, let's say you're interviewing for an IoT based company, and you already know what kind of products they make. So when you arrive for the interview and you know already that these are the types of products that they manufacture, when you give your example of a particular implementation, you can say that this is how it can be used. For example, in your IoT device, when we try to connect through Wi-Fi, these are the challenges that we will encounter, and this is how we can do it via this programming scheme, right? And this is how we can interface XYZ sensor in order to solve this problem. So you can tailor your answers to kind of be in line with the product that they are already working on. So that kind of gives the interviewer a sense of, you have a sense of what is going on, and you have what they're looking for. And during the interview, I would say keep your answers precise. Give a probable solution. Try and logically answer the question. Here, I would say it's a balance. Some people say that, and we are taught as well in our engineering, we are taught, when you appear for a Viva, say something. But it's not true. It doesn't hold good in all situations. So you can provide a probable solution of what you think of how it is implemented. But if you do not know uh, uh, the answer to it, I would say you can admit that you do not know and that you're willing to learn. That's something that you want to look through later on. And also, I would say give examples. So there is there is something called as the STAR methodology that people often follow. So it's the STAR abbreviation stands for situation, your task, the action, and finally the result. So when you are asked with a question of what will you do in a situation, or what did you do, or how do you solve this, then when you explain your answer, you can describe the situation that you encountered or the problem that you had at hand. What were the tasks that you thought, or what were the fixes that you thought you would implement? What action did you take? And finally, how you were able to solve it. So I would say you can tailor your answers in this way, so that you are able to better articulate how you went about solving a challenge, or even are trying to attempt to solve a problem. And always play to your strengths. So try to build your answers on your experience and what you had done in your code in order to solve the problem. So let's say you had a question on the structures, and then you can say, yes, I worked on this, and this is the way that I implemented it, and that's how we can update the structure elements in such and such way. All right. So going forward, we will look upon how to deal with massive frameworks, code bases. This is a challenge that any and every of you will encounter when you start your career, be it AutoSAR, be it IoT, be it ML, be it any domain. You will come across software frameworks which are thousands of lines of code, and probably million. So how do you deal with such large code bases? How do you even begin to understand? So because you will be given a task to implement something, and that often happens with people who move into the Linux kernel side of things. Unfortunately, in my career, I did not have the opportunity to move into Linux, but people who work on Linux environment, they usually know this. It's a massive framework, right? So how do you start to understand? So in my experience, these four approaches have always worked. And I would say begin to abstract things first. You generalize the functional blocks of your code section. You see what your code philosophy is. And how you do this is trying to read some documentation, because the documentation generally abstracts the entire software philosophy into blocks, and you begin to understand where the data flows. You focus on what you need to understand, because there are times where you just get lost in a massive framework. If you do not know what you're looking for, then you will be stranded on that island for weeks, and there'll be nobody to help you. And that is what becomes tiresome. It frustrates you, it annoys you, and it kinds of brings down your motivation to work, because you are unable to just even understand the framework even to start working on it, right? So focus on what you need to understand. Check whether the blocks align with or the functional blocks, I mean here, they align with the objective or the intended operation. That is your problem domain, right? So let us say you are trying to implement a kernel module. Let us say you are trying to implement a low-level feature, right? Or an application level feature. Then you need to understand how data flows. And so when you refer to the documentation, you will try and, because all of the code that you see is cross-referenced by many modules. And you start at one place and then you come to a crossroads, then you get into one of the crossroads and it further divides up into many other roads, so you get lost in this labyrinth of code. So I would say try and identify the data flow, so you can understand how where your data is intended to go or where the data you're waiting for comes from. So in both ways, it kind of helps. So read the documentation, try and get a high level description of the framework and software stack. So this will start to, your mind will start to piece together the information that you come across, right? Pay attention to folder and directory structures. So once you have your code base or stack downloaded, try and see the folder structure, because you will know which folders to avoid looking into when you kind of try and investigate your code. So investigate the implementation. So let us say you were supposed to implement a logic or a particular feature, but you don't know how to do it. It's a new framework. You've not handled this before, and you have very limited understanding of this framework. So try and see if there's a similar implementation that another feature uses, and see how the data flow works there. In that way, you'll be able to infer or deduce what you need to do in order to go about designing the solution for your implementation, right? So refer to the previously implemented code. This again is something that we tend to forget or overlook, right? So it might have been implemented on a different kernel. It might have been implemented in a different project or a platform, but always try and see if you can get a hold of the previously implemented code so that you can see how it was done earlier. Because what you're trying to do now, it might be a different format or it might be a different approach, but it's not that it has never been done on planet Earth. So always look for previously implemented code. Make complete use of code editors. Try to understand how code editors work. It's a very powerful tool for you to trace calls and references and navigate through code in a very fast manner. And always discuss. So reach out to application developers in the community, ask questions on the forums like Stack Overflow. Try to reach out to your team members. And I haven't included that point specifically here because sometimes your team members and your team leads and people who are experienced are held up with other complicated stuff, and they might not be able to kind of help you out immediately. But I would say reach out to the application developers in the community. Ask them. Stack Overflow is usually very brutal in my experience, but there is no option. That's what makes you a better software engineer. You go there, you get spat on, and they say that you haven't seen this, why haven't you done that, why your question is missing a chunk of information, etc., etc. But you go back to them and you ask and you learn. So we had, I believe, Yashoda, right? She was asking us, what skills must I work on? So this is a question that even I had. What other technologies should I learn? Is this sufficient? So I would say, in order to enhance your skills, right? Research about other embedded ecosystems. This is where you start looking into implementations, real world implementations. You go through different websites, go to the websites of different microcontroller manufacturers. They have applications, they have application examples of, let's say, if you were to visit Infineon developer community today, or their website, and you go into consumer electronics, let's say consumer electronics, you would have a sample application of running a cooling fan and all the ICs that go into it. So it's a marketing strategy that they use, but you get to know what are the blocks that go into these embedded ecosystems, and then you can try and understand what you can go a level deeper, try and understand how it's done. Familiarize yourself with technologies as you stumble upon new technologies. So new terminologies, I mean. So you will come across many terminologies, for example, MPTPT algorithm, model predictive control, you can say, path planning, trajectory analysis, and, motion control, obstacle detection, collision avoidance, right? So these are words which are alien to some of us, but try and understand. Don't shy away from exploring these terminologies when you come across these technologies, right? Build your understanding on control theory. Now, this is very important. This I have learned the hard way, but it kind of takes you a long way in your career, that you understand some concepts of control theory, because your systems implement this directly or indirectly. So once you begin to look at any product or any system in the scope of a control theory engineer or a controls engineer, you will understand what are the things what is the type of data it's dealing with, what is the data processing that it needs to do, what are the inputs and the outputs. So that kind of helps you get a different perspective. So try and build your understanding on control theory. I would say try and watch YouTube videos on control theory to start off with. Explore motor control algorithms and schemes. Now, motor control is is uh, is something that I see being used everywhere, right from EVs to consumer electronics. So, in order to be able to have good efficiency of your product, and also be able to meet the operational efficacy of your product, you need to understand how motor control is done wherever motors are used. Try writing bootloaders and linker scripts. Sorry, the spelling of bootloaders, I just realized it's wrong. So then understand how firmware update over the air works. What happens when you have a new software image that is deployed? How does it arrive on your phone? What actually happens? How is the switch between the images made? What actually takes place on a microcontroller level? Try and understand this. Try to automate building scripts using Python. You can also build a test environment. For example, you might want to test a communication interface. So let's say you have a USB based communication where you're data logging, and you want to get all of the data, and then you want to plot what happened over time. So there are different ways of doing this, but all of this is made faster and easier when you work with Python. And when I joined Ati Motors as a first task, right, in Ati Motors, I met my ex. And by ex, I mean maths. I I was a person who kind of detested maths. I was really scared. I had the math phobia. But the first task that was given to me was research papers, which was filled with a ton of equations, a ton of equations. So in order to simulate, battery discharge conditions and cell characteristics of lithium ion cells. So in order to do this, they asked me to use Python, and I had not worked on Python ever in my life. And they passed on a document to me from Dr. Vishwanathan Vinay, which said learn Python in 1 hour, and I was supposed to deliver the simulation by the end of the week. But I would say if I was able to do it, then all of you it's going to be a piece of cake for all of you, because if a person like me could implement it, then anyone can implement it. So learn Python, learn to automate with Python, try and understand the features it offers, and really how you can tie it together with your embedded application for software, validation and verification of your product. Read about MPPT in solar charges. So it's a very interesting implementation. Have you ever thought how these solar chargers work with solar panels when there is continuous fluctuation of sunlight because of the clouds and weather conditions? And how can you extract maximum power? Very interesting algorithm. So battery management systems, lockstep. This is a word which most of you would have never come across. That this you see in automotive domain, where the image runs on both cores. This is a security feature. And how does this work? How does code execute exactly at the same time on two different controllers? Maybe something to read about. Direct memory access, concurrent and defensive programming techniques, uh, OS concepts. security modules and the crypto engines, hashing and paging, memory interfaces and protocols, cloud services, wireless technologies, code analysis, static code analysis, different race conditions, and how do you handle race conditions in software implementation? How do you implement debounce logic? Because when you are given an evaluation kit in your company to start understanding how the controller works, uh, you will have some sort of an input that needs to come in, and we will generally configure a GPIO which is connected to a button. But there is debounce logic that needs to be implemented, or there will be a false positive that will be detected and your code will fail. So you need to implement a debounce logic. How do you do that? Read about it. Read about understanding how you can apply filters for your data. Understand PID loops. This is again a part of control theory. State, how do you design a state machine? How do you move from one state to another? And what are the working principles of certain sensors, electronic components, and the list goes on. So I would say that as a start, as a start you can begin to look at all of these different technologies, read about them online, because the actual answer here is you have to be inquisitive, you have to stay curious, you have to develop a mindset where you're willing to learn new technologies, even if it takes you out of your comfort zone. And these are technologies which are in use, and that's why they are on the internet, and that's why they're related to embedded applications. So try and understand. You cannot do it all at once, but um, remember that persistent, continuous, measurable efforts always pays off in the end. And basically, if you look back on if you spend time on all of these topics on a daily basis, and you look back after 5 years, it's the integration of all of your efforts that finally pays off the sum. Okay, so let's talk about some of the hurdles and challenges, right? This is something which I want to speak about, because you saw me blabber about my entire professional career and history, but I'd be lying to you if all of it was just a walk in the park. It was not a bed of roses for me, it was a bed of razors, because it came with its own challenges. And there were hardships, there were setbacks that I faced. And this can happen to anyone, because all of us are from different socioeconomic backgrounds. We have different family conditions at home. Your parents might be retiring, and now the responsibility falls on you, and you have all of this in your personal life, and now you have to balance it with your professional life. And there might be things that you might encounter in your professional life that kind of demotivate you, but always go back into analyzing every situation and try and see how you can work your way out of it. So always assess the problem when you find you're in a difficult situation, especially with regard to your job. Try and understand what is the problem. Is it an internal factor? Is it something that you think is not solvable, achievable? What is bothering you? Are there any external factors that are affecting your productivity? Try and understand what makes you feel that your job is overwhelming, because sometimes I can empathize with a lot of us, and I have been through this myself. You are under tight deadlines to deliver. Um, you uh, you have a lot to learn and then implement, and also make it a production worthy code. So all of this comes to you at one go, and so you end up feeling overwhelmed. And try and understand, why are you feeling that way? What can be done in order to solve it? Would it be solved if you received help from anyone? Or is this help something which will kind of temporarily fix the problem? Or can it be dealt with once for all? How do you go about dealing with it? So, like, for example, the example of the software stack that I spoke about, right? You can quickly approach your team lead and say, how do I implement this? And he says, okay, fine, go ahead, do this. But you don't have a conceptual understanding. So it's a temporary fix for you. You implemented, you delivered the code. But what happens next time? Your team lead might have switched his company, and there'd be nobody to help you. You will be the team lead. So try and understand, both the long-term and the short-term effects and implications of your decisions. Is the environment competitive? Is there a lot of performance pressure? You need to think about it. You need to understand how you can handle it. Is there low motivation? Is the job not interesting? So this is again a factor, a challenging aspect of any job. And what I have seen most of the time is that low motivation is because you are continuously posed with challenges one after the other, and you are tired, and you don't have the energy to go about solving it. So how do you keep your motivation up in these situations? I will talk about it in the coming few slides, because this is something that we really need to tackle, going into a career where the domain is vast, right? uh, um, I remember when it comes to pressure and anxiety, right? I can quote the example of my first company. Um, I was new on the job. I had to implement this balancing algorithm. I had to bring up multiple interfaces, and what happened was, one of my managers at that time, he would pull up his chair, sit behind me, and look at my screen while I'm coding. And he would say, "What is this? Are you even? Yeah, did you even learn C programming? Is this the way it's done? Did you even complete your master's degree?" So that kind of kick-started a kind of an anxiety in me where I would freeze, and it took some time to overcome that. But uh, I would say that even though it was very challenging me to deal with it, because I dealt with it, uh, I'm able to handle other challenges with ease. We had long work hours. We would stay back in the companies for 13, 14 hours, and it would really wear me down, because I had to travel 25 kilometers up and down, trying to get the job done, trying to constant monitoring and supervision, micromanaging. So these are challenges that you might face. I'm not saying everybody will face that, but always know that there is a way out of it. Always try and stay motivated, because finally the motivation, you're the only one who can help yourself climb out of the cave. So understand what excites you about your job or skill. So this is a part of the assessment that you need to do. What really makes your job satisfactory for you, and why you want to be in this job, and therefore why you need to work harder. Some people say that hard work beats talent, right? But hard work is talent. It is a talent in itself. So you will get somewhere. uh, Again, going back to the quote from my mom, always aim for the moon and you land on a tree. So it kind of falls in place. If all else fails, remember this, everyone: semiconductor is a $1 trillion industry, and India is making huge leaps in this domain. So understand that all the money would finally come back into the semiconductor industry. Therefore, you be trying to be an embedded engineer makes more sense. So how do we keep up the motivation, right? Keep the lamp burning. Um, I would say, from my experience, take up hobby projects. I've done this many times, and I have worked on the most silliest products. I've worked on good products. I've worked on innovative products. Uh, but take up hobby projects if you find the time. I used to consult for few companies once I had some experience, and this is something that all of you will encounter, right? You now get into your first career, and you start to become a code warrior. You understand, okay, you're able to establish I squared C and SPI communication. You become a master of APIs. You realize all of this is just a game of APIs, and now you are suddenly all confident, because you have worked on certain technologies which are in demand, and then you'll decide, I'll start my own company, right? Easier said than done, but I would say try to consult uh, in your spare time with companies which are looking out for embedded engineers, right? It's a very good it's a very good opportunity for you to get your brain to exercise. Then we are creatures of habit, so you need to inculcate a mindset where you're trying to learn, because learning never stops. The entire idea of your life or your existence or purpose in life, because you have done engineering, is to be a better engineer. Everything else falls in place. You being an embedded engineer, you being a full stack developer, you being XYZ developer, all of this becomes fulfilling for you when you yourself try and focus on becoming a better engineer. Your entire life is a pursuit of you becoming an entire engineer, and that's how I see it. Watch YouTube lectures, follow different channels and people, uh, visit massive open online courses. You have a lot of Udemy courses which offer, which kind of step you through every implementation, technology. Make use of it. Take up certifications if possible. It'll always add value to your resume. Teach programming to others. Do not be selfish. When you see a junior, let's say you have worked in a company for 3 years, right, and you know the product in and out, and a junior joins, they are not from, they are probably from, they are basically fresher. They don't know anything. So your attitude should not be that, let them suffer like the way that I suffered. Let them learn everything on their own. Why should I help? But be more altruistic. Try and be helpful. Try and teach programming to others. This is one of those things where the more you help others, the more you learn. And I think you have seen this in action in Emertxe, right? The more you teach others, the more you learn. Try and solve lead code problems. Play with sensors and evaluation kits if you are able to get a hold of them. Think about cross-platform integration, right? This is a very fun activity that I like to do sometimes. So all of you are today engineers. All of you have know how to control a DC motor, servo motor. What stops you from implementing or constructing a chapati maker for your mom? Nothing. Is there something which is complex? Is there a logic or a software stack or a frame that you need to implement? No. So think about how you would try and put together your embedded system skills and knowledge to serve your own purpose. And that's what makes it really beautiful. Write libraries and utilities if you are really a code oriented person, and you really want to have something accredit to you. Write libraries and utilities. Come up with kernel drivers, device drivers. My manager from one of the companies where I worked for, he has a good name in the Linux community because a set of his driver implementations got accepted into the kernel, and that's a huge accomplishment. So try and exercise your aptitude and aptitude here in writing libraries and utilities. Participate in code reviews in your companies, in your organizations. When they have code reviews, try and try and actively be a part of these meetings, because you might come across a logic that somebody has implemented. Maybe you are able to suggest better optimizations, or maybe you get to learn a new implementation that you have not come across before. There's an easier way to do something that you've already been doing, and it generally builds confidence. So participate in code reviews. With this, I think I have answered most of the questions that we have. We will now look into building essential skills as an embedded professional. So please bear with me. It's for me, it is a little monotonous with me speaking continuously, but please make sure to write down your questions, and I'll try my best to answer them. Right? So what are the essential skills that you need to have as an embedded professional? These are the immutable skills, right? They are your programming skills, your debugging skills, your conceptual understanding, and your familiarity with hardware debugging tools. So in a real life environment once you start to work. And I'm sure that people who work here, who in this call, can attest to this, that apart from your programming skills, it becomes crucial that you know how to debug, what tools you can use in order to debug to solve the issues that crop up. So programming skills is again immutable. It helps you implement better code, efficient, optimized C code that adheres to coding standards. You need to be able to have debugging skills, trying to take logs. Your debugging skills usually I'm speaking in terms of an embedded engineer, right? You can log your faults. You can toggle LEDs to understand your code flow. If you're not able to log, if it doesn't have a UART provided on the hardware, or any communication interface, you can apply breakpoints in your code, try and see the code and data flow. You can see call stacks for your function call invocation. You can see your memory dumps of your registers. In Linux you have GDB, you have embedded trace on ARM controllers. So you improve on your debugging skills, and spend time on your knowledge of basic electronics, circuits, active and passive components, certain ICs like voltage regulators, and communication devices that you can use um, in order to log your data. Try and read and interpret schematics and data sheet. So you'll be working with a lot of sensors. You need to refer to the data sheet. You need to be able to see the schematics. So you need to have some understanding of how these circuits are implemented in order to trace the problem. Because sometimes all problem is not software oriented. And as an embedded engineer, it's not sufficient that you know just embedded C, because you are working on a hardware, you're working on a controller, and that controller has a few hardware configurations that you need to be aware of. Debugging tools, your in-circuit debuggers that come along with program for your programmers, for your controllers, how to use a multimeter, how to make use of it. I'm sure that these are something that everybody at least understands to a certain extent. But I will give you a real life example where one of the engineers, um, in the first company where I was working for, used the continuity mode when our battery management system was live. The board was powered on, and in order to try and understand if the interface is connected properly between the controller and some other component, they used a continuity mode in the multimeter, and it shorted the board. And what makes it dangerous is because lithium ion cells can have thermal runaways. So if there is a short on the cell, a lithium ion cell would explode, and it would set off a chain reaction, a cascading effect, and we would end up burning the entire company to the ground. So be careful, try and understand how you use multimeter, how you can utilize it. Uh, Learn how to use an oscilloscope. We had some basic principles. Usually in engineering, we don't get to spend time with oscilloscopes because it's a much coveted device, and everybody wants to use it, and we have very limited time to interact with the oscilloscope. But oscilloscope is so powerful if you begin to understand how you can utilize it. Try and understand logic protocol analyzers. This will help you solve a lot of your communication interface problems. It will help you debug and show you the data that is being sent, rather than you having to look at waveforms and manually decode the data that was sent. So I would say that these are the essential things that every embedded engineer should be aware of and should be well versed with. So coming to oscilloscopes, protocol analyzers, and your debugging skills, uh, where does it all come together? It comes together when you are posed with a challenge, or you come across an issue or a problem during your development, and even during sometimes, unfortunately, uh, when your product fails on the field. And so you need to be able to solve the problem quickly. And how do you do this? How do you handle this challenge? That is something that I would like to talk about. And we'll focus on problem solving. Again, I would encourage all of you, if you have any questions, please make a note of them so that probably I can answer them later on. So, without further ado, this is one of my favorite topics to talk about, and that is problem solving, right? Um, so, why do we need problem solving? What is the importance? Um, in my experience, you need to have a good problem approach and solving skills, and that is because you need quick resolution. You know, in order to identify the bug, what fix can be applied, and even if you imply or apply those fixes, what implications does it have on the overall subsystem, or even the subsystem or the subsystem in general. So quick resolution. So in field issues, as I mentioned, they are disastrous and they cost the company a lot. So even you would see, if you follow the news, many car companies have massive recalls uh, because of some or the other field issue problems. And car is safe is critical, right? Because it involves a human life, and so they have massive recalls, and these recalls cost the companies billions of dollars. So field issues are very critical, and so the developer is under immense pressure to solve the issue quickly. And if the issue was traced back to some feature that you have worked on, then you're in the soup. So you may try to end up with a quick fix and say that, you know what, I am going to make these changes, I'm going to comment these lines of code, I will add this, I will change the data type here, I will make this static instead of const, and all of those kind of quick fixes. But those quick fixes may end up introducing far more sinister bugs. So with bugs, we come to identifying the bug, right? Because you should be able to even you understand what is exactly causing the issue. And you compiled it, you had your bench tests done, there was no issues, but there was a bug in the field. So these issues are usually very elusive, and they tend to lurk behind very good looking and well commented code. This is something uh, that you will see once you begin to work. Semantic errors may be very hard to identify. And for this very reason, there are very powerful static code analysis tools. But in case you don't have the access to such tools, semantic errors is usually missed, and it might be probably a part of the code that you have implemented or somebody else has implemented, but the problem exists somewhere. So problem solving plays an important role in scoping out such probable causes. Then risk assessment, right? And to talk about the bug, right? Sometimes you might introduce a bug into the system which actually becomes a feature. So this is a joke in the community where you say, the bug became a feature of your device. But always remember, your feature should never become a bug. So risk assessment, right? Certain issues require to be addressed by cross-functional teams. So it's not only about you, it's not only about the code that you've implemented, but because it is a part of a larger system, there might be other modules which are affected, or other modules which interact with your software module are what is causing the issue. So you need to be able to address the issue cross-functionally with different teams. Trying to resolve a bug locally on your own without involving the different stakeholders, as we call them, the correct term for the team members, may put the company at risk, because you might have a quick fix out, but it might end up affecting another module and it might end up breaking the entire system. Do we even need to fix the bug immediately? That's a question that you need to ask. This is a counterintuitive thought process where you say, do we even need to fix this bug immediately? What repercussions does it have? So I lay out two scenarios for you all, and I want you to take time and think about these scenarios, and we'll try to address how we would go about solving them. So let me give you this scenario. Okay, this is your problem statement. So you've joined, you're working as a preliminary task, the Rev 1.0 board what the hardware team has conjured up. They will provide this to you. It has been provided to you by the hardware team for basic verification and bring up. The onboard controller is interfaced with two I2C sensors, which are present on the same board. Though you worked with other similar I2C sensors previously, you have not worked on these sensors in particular, which is all right. You are unable to get these sensors to respond. What will you do? So this is a situation and a scenario that I present to you all. In this situation, what would you do? Think about it. Try and brainstorm. What are the things that you will check for? So this is your issue, right? You're given this board. Hardware team says that it's a very simple verification. Just let us know if the interface is working. Get back to us by the end of the day because we have to release some files, the Gerber files for the next revision of the board. So you're not able to get the I2C sensors to respond, and you need to complete this work by the end of the day. How would you go about solving this issue? So you would say, okay, so let me check if the I have the correct slave address configured. Let me check if the pull-up resistors are configured, because that is the first answer in every interview question. Pull-up resistors must be present. So say, okay, fine, you check your pull-up resistors, and then your device is still not responding. The sensors are still not responding. So then what do? Then you start to look into the data that you're sending. Okay, and then you start to look into maybe a hardware connection issue. Is there a hardware connection issue? Is the slave device actually working? Is the microcontroller able to communicate properly? Let me bring out my oscilloscope. Let us check if the data is being sent. Let me probe the pull-up resistors if they are actually connected, if they're pulled up, if the SDA and SCL lines are pulled up. So you begin to slowly work on these or come up with questions in order to debug it. But it requires sometimes that you think out of the box and come up with debugging strategies and think of it in all other possible ways, rather than to focus only on just communication interface, the IC, microcontroller. They are the main things that are involved. Yes, I agree. But along with those, it's equally important that you try and think about all the other hardware aspects and software aspects that play into this, right? So let me propose this solution. This is the way that you should actually try and come up with questions and brainstorm your possible approaches, right? So from the basic 4, 5, 6 questions that we discussed, that now has expanded to all of this. So there is an opportunity for you to brainstorm so many possible questions that you can begin to tick off from your checklist to see whether that solves the issue. So for example, in software, right, was the I2C configured properly? Had I configured it in master mode? Was the clock divider set properly? But from the clock tree, which clock tree am I using? Because a controller might have different clock trees. Were the pins configured correctly? Am I using the right pins? Just because it's I2C, I might have configured I2C on two different pins, which are different from what is configured on hardware. So are the pins configured correctly? Was the I2C even initialized in the main function? Is the slave address configured properly? Does the IC support the baud rate? Did you read the data sheet? Usually I2C ICs or sensors which support the fast I2C mode of 400 kilohertz, they are backwards compatible. But what about the scenario where it's vice versa, where you're trying to communicate to an IC at 400 kilohertz? So you need to check your configuration. Do we need to send a command before every data write? And if you guys remembered, I mentioned two ICs that I worked on when I started my career working on battery management system, right? They were the LTC 6804 and 3300. And that's how I remember this, because the IC, you might try to request for a data, and you are happily using your hardware abstraction library calls I2C write, I2C read. But there might be a possibility where you actually need to send in a command byte even before the device response. So do we have to send a command byte? Let me look at the data sheet. Do we need to calibrate the sensor? Is that the reason why it's not responding? Do I need to send in a calibration command? Is there a read configured to, is the I2C configured to be a direct memory access through MMIO? Was an interrupt configured? If an interrupt was configured, did it occur? Was it cleared? Can we confirm with call stack what's happening? Is there a software controlled enable pin for the IC? Was it pulled up before the reads and writes? So these are things that we usually overlook. Must we send a CRC along with the data? Again, check the data sheet. Does the IC provide the data ready pin? So usually, sometimes some sensors might take some time to process the data for it to be a valid data. And once the data is ready by the IC, it usually toggles a pin for data ready. So was this configured? Is this configured as an input or an output on your microcontroller? Was the data sent in big Indian or small Indian? Some controllers offer this option. So you need to think about these questions. On the hardware side of it, uh, are the I2C pins configured properly? Are they connected to the right pins that I have configured in my software? Or was there a mistake in connecting the I2C pins on the hardware? Where the pull-up resistor is populated, does the I2C, the I2C IC usually have address pins, and that's how you have a single master multi-slave environment sometimes, right? You have multiple slave devices, and all of these slave devices have address bits. They can either be set through software, or most of the ICs offer address pins. They are A0, A1, if I remember properly. They might not be named A0, A1, but the address pins are usually what you can configure on hardware. And are you sending the slave address with the same hardware allocation? Is there a hardware enable pin for the IC which is pulled up? So in order to enable the device itself or the IC itself, there might be some pins that needs to be pulled up. Usually, what happens is uh, when you design, or even when you try to come up with a circuit, you might have missed pulling up this pin. You might say, okay, maybe we'll put up a pull-up resistor here, but then you would have overlooked it and you would have connected to a pin of a microcontroller. So then you need to pull up the pin in software. So you need to understand whether there's an enable pin. Was the IC powered on, first of all? Is that the reason why I'm not able to communicate to the IC? Does the IC provide a data ready pin? This we already spoke about. And sometimes, right, it might be possible that when you work for smaller companies where the assembly is done in-house, that there might be dry solder. The IC might not have been soldered properly onto the board, and that's why you're not able to communicate it. Now, you are stuck if you do not take into consideration this angle, and you do everything on your software and you see your hardware, everything is populated correctly, or address bits are configured, but then why is the slave device not responding? So there might be a dry solder, and that's something that you need to think about. So come up with questions, come up with different scenarios and possibilities. Do not limit yourself to just whether I've initialized the I2C configuration or not. Then Does the oscilloscope or protocol analyzer waveforms match my expectation? Is it of the right frequency? Am I seeing the start conditions and stop conditions for the IC for the I2C communication take place properly? So that's is the clock rate fine? Is the STL line low? And is it observable on your waveforms? So is there a data processing timer for the IC? We spoke about this, right? So sometimes this might be one of the reasons why you're not getting a response of the IC. Okay, so I will now present you with another scenario, right? So I hope you are beginning to get a feel of what debugging actually means. It's about coming up with different questions and considering different possibilities. So from this example, you have already some idea. And now I want you to start thinking what happens in the next scenario. So this is your problem statement, all right? The product release date is nearing. Your code was programmed onto the final or production version of the device, but the device has failed the field test. The code worked properly and perfectly fine during your bench tests. Now, what do you do? How do you even start to look into this problem? How do you identify the issue? You need to solve it because the production is nearing, and now you have a deadline. You are rushed to come up with a solution and try to find out what's happening. But you know for sure that you have tested all the possibilities when it was on your bench. You have you made sure the hardware was fine. You made sure the software configurations are fine. It is a working code. You're very confident about your code, but something is happening which has failed, and they know that it comes from the software code that you have implemented. How will you go about solving this issue? I'll give you about 10 seconds to think about and come up with questions.
Guys, please let your questions come in.
And also, Kavya, you need to let me know if I'm taking up too much time and if I need to step up my pace.
No problem, Pranith. I think audience are waiting. You can take your time.
All right. I want to thank all of you for being patient with me, but I hope all of this is interesting to you all.
Yes,
Okay,
Pranith, it's a great learning opportunity. Please take your time.
thank you. I hope everybody feels the same. All right. So let's look at the solution, right? Of what questions you can come up with. So I said you were confident with your code, you know you tested it well, you know everything was working. So now what do? You come up with these questions. When did the problem occur? And this is the critical analysis that you need. This is the critical thinking cap that you need to put on and step aside from just being a embedded programmer and think about, did I do this routine correctly? Why wasn't this done? This routine was there, that routine was there. I should have debugged, I should have logged it. So I want you for all of you to step aside from the programmer perspective and move into a critical thinking person to try and understand the problem at hand. So this is your problem approach. So you kind of come up with questions. When did it occur? What were the conditions at which this problem occurred? Can we plot and look at the data? Can we understand from that where it went wrong? Is it reproducible? If we do that and execute it again in the same conditions, will it throw up the same problem or the error? Can there be external factors that could have caused it? Some mechanical fitting, an increase in temperature, some IC was loading, or some other connected device was loading it. This is an out of box perspective, right? What changes were made recently? Whether changes made in software and hardware? Did somebody update something? Was there a change in the hardware revision? Were there any touch-ups or hot wirings made on the board, or was it not done? So you need to be able to think of the not of things. You need to, sometimes your approach needs to be counterintuitive, right? So you would have already, let me give you an example, and I and I remember this from Emertxe. Mubin sir had given us a problem. So it was like the second or the third week of me being at Emertxe, and Mubin sir said, "Okay, everybody, write a code for a simple calculator." And I always remember this example because it kind of showed me something that I had not considered before. And I said, "Oh, simple calculator, so easy. Let me just put in addition, choose your option, addition, subtraction, multiplication, division. Oh, division, I have to be careful. I need to handle the divide by zero, right? So let me make progress. Let me be better than the other students and include this error scenario." And then we would code it, and then Mubin sir would come, and then he would just put in some float values, and then my calculator would fail. And then I said, okay, fine, let me handle a float. And then I said, "Sir, okay, it's done." Then Mubin sir would come in and write and type in characters. So your code, right? When you have designed it or implemented it, if it has not undergone a review, and you have not captured the error scenarios that can happen, that is the not of things, right? You never expected that characters will be put in as an input, but something has happened and it caused your implementation to fail. So you need to think about things which are the not of things. What if somebody else puts something else? It's something that you can think about. So can it be simulated? uh, because simulation helps you try and understand and catch bugs beforehand. Is the component working properly? Can we run a benchmark test? Can we quickly just do a read to the sensor and read back the hardware revision version, just to make sure that the interface is up? Did you program that into your module, into your code? A basic check to see that the slave device is up and running. That is something that I had to do when I designed the battery management system. Are the voltage levels and power signatures as expected? Is there something loading the device that is causing a fluctuation of the microcontroller that kind of caused it to fail? Is the connection interface severed? Is there loose contact? Can you get back the field device, try and see if the connections and connectors are proper, probe and check for voltage levels for the signals. Was there an EMI causing spurious values? Are we using a shielded cable? Is there a potential EMI noise source in the vicinity? Now, these are things that you do not think about as a embedded programmer, right? And we have seen this happen. So when we were designing our prototype, which I showed you, P0, thankfully, we were none of us were hurt. But when we would issue a command, PWM command, in order to run the motors, something would happen, and it would end up turning the speeds at a very high speed, and there would be a runaway of the vehicle. And you can imagine what would happen if there's an autonomous vehicle running loose, trying to kill everybody. They would have banned us from our Indian Institute of Science. But what were these issues? So what we saw that some of the communication or interface cables that we had interface our motherboard with the motor controller were close to the motors, and motors are good emitters of EMI. And if there is a sufficient EMI which is induced into the wires, then there is a change of your PWM values. Your motion control will not be smooth, and it will be very intermittent, and there is a possibility of a runaway. I remember there was another issue where we used to send the PWM through our optocouplers on our next revision of a board, and when we connected it to the motor controller, our simulations were fine, our tests were fine, Our voltage signatures were fine when we tested it, but when we would connect it to the motor controllers would load for some reason, and then there would be a drop in voltage, and that drop in voltage across the optocoupler would be inferred as a different command, and the motors would start running at high speed, or one in anti-clockwise and the other wheel in clockwise, and the entire vehicle would just spin in the spot because it was a three-wheel vehicle. So is this something that is done in software? No, but this is out of the box thinking. Try and check electrical grounds. Are the communication baud rates correct? Now this you would have already done before you kind of came up with the production ready code, but again, it doesn't harm to kind of check these. Change one variable at a time, or use a method of elimination. Try and see, try and abstract your problem. Try and see, okay, what if I comment this line of code? Is this what is? Sometimes the section of the code that you have written may not have anything wrong with it, but the data that is being sent to you for you to process, that module might be going wrong. So try and eliminate one after the other, one variable at a time. Try to understand where the problem is originating. It's called the method of elimination. Check for any corner conditions that are causing fluctuations. Visit the state machine conditions. Now, if I today were to pick some of you, including myself, and I would say, let us come up with a hospital bed which uses a DC motor to kind of host up the patient, and it uses a DC motor to make this operation come true. If you have not implemented the corner case condition of what happens when and how it should get to the position, you will fold the patient in the bed and get him. You'll kill that patient immediately, because we'll say, okay, the command has come from the button from the patient to move the bed upwards. Let us do it in full speed, and you give full 100% PWM on your motor, and then the patient will be sandwiched. So you don't want that to happen. So you need to take care of conditions, corner case conditions. What happens when there are fluctuations? So let us say you are checking in your code that after a certain voltage you want to turn on cooling, right? Let's say you're writing a logic to control the cooling fan for your controller or motherboard, and then you say, okay, if the temperature ADC value is greater than x degrees, then you will switch on your fan. So you reach x degrees, you immediately switch on your fan, the temperature reduces, and then you turn off your fan. And this keeps fluctuating because it's a corner case, and you're switching on and off and on and off. What happens is, over time, there is mechanical degradation of the fan. Your product will not last. It will come back with issues after 1.5 to 2 years down the line. Consider corner cases. Check the timer or system modules. Does the overflow occur that has caused it to fail? And this happens commonly when we have implemented software timers that we do not handle the rollover conditions properly, or when the rollover occurs, we do not set the necessary flags to reset the timer. And this might sometimes cause a lot of issues. So be mindful of it. Are global interrupts disabled while initializing peripherals? Are they properly enabled before the scheduler starts if you're using a FreeRTOS environment? In what power mode did the fault occur? Or which power mode transition? Did the problem occur after the product was put in low power mode? And for example, take the example of a device tracking product, right? So it's installed in your car, and that is the product your company has come up with, and it goes into a low power mode transition when the vehicle is not in use. And the first few times nothing happened, you have tested it. The first few times the customer did not find any issue, but on the 7th time or the 21st time or the 52nd time, something happened after X number of iterations. So what's happening there? Did it happen because of X number of power mode transitions? Were you actually capturing this somewhere in the memory? Did you not handle was it assigned to a variable which was just uint 8 and has exceeded? Was there a rollover? So you need to think about these things. You need to consider these kind of situations. Was the memory section protected? Was it overwritten by any chance by some other module? Or if it was a multi-core environment, was it overwritten by the other controller that caused this to happen? The actual problem always, right? When you are sure about your code, it will always reside few lines up the code. So try and see the data flow. Try and see whether an erroneous data was provided to you by the previous function, which caused your function to fail, because the control logic might reside in your function and you take decisions based on the input data, right? Consider the use of, you know, the consider the use and of data which kind of meets these corner case conditions. So counterintuitive approach, maybe even in your software development stage, counterintuitive approach may be even helpful for you to debug, because you actually do the opposite of what you're supposed to do. For example, there is an error. You need to find out where the error is occurring from. So why don't you introduce another error into the system? Why don't you give it wrong erroneous data? Try and introduce an erroneous data into the system. You're supposed to solve the error, but in order to solve the error, reintroduce another error and let that error help you find where the problem is. It's a counterintuitive approach. But one thing is, please remember to comment that line of code or delete it after you have done all these tests. And delays, introduce stubs. Stubs are basically placeholder functionalities that you can implement to kind of see, try and simulate how the code works. So I hope this gave you a kind of a perspective of, what goes into problem solving and problem approach, and where you need to switch context while thinking about it in terms of a software programmer, in terms of a system level integration, a deployment. So you need to be able to develop this kind of a perspective of the system. And these are golden nuggets from my years of experience. And I only wish that when we were in Emertxe at that time, we had webinars such as these. If only somebody would show us the way. Right. So problem solving, right? It leads into this. And this is what I wanted to talk about. And if I had spoken about root cause analysis on the first go, without getting your brains to start juicing up and thinking about the things that I've spoken about, then it would have not made sense. So this is root cause analysis when they say try and find out what the error is, right? So you try and define the problem. You technically describe the problem at hand. You assess the areas of impact. You see what are the functional and operational features that it has affected. Most of the times, defining a problem technically already solves 70% of your problem. And it makes it easier for you to communicate with other team members what is happening. It's very clear. When you technically define the problem, it's very clear across teams where the data is and what is causing the data. Then try and see the general causes, right? Try to understand the basic functional blocks that contribute to the problem. Abstract it. Okay, this involves ADC. This involves some PWM control based on the ADC, and that's where the error is occurring. So you know that ADC is involved. You know that PWM is involved. So prepare a first level checklist. Initializations, configurations, connections, interfaces. Try and see where the problem can lie. Then you go in a level deeper. You identify the specific causes. You try and see within each of those functional blocks what can contribute to the problem that you're observing. Data handling, code implementation. You study the data flow again to see whether there's any interdependency in the module. Can a sensor failure actually stop an entire lunar module from landing? It is possible. If I remember a long time back, I was reading this article where on the Apollo 11, the landing module had few issues where it would not deploy because some sensor integration was not, or it was erroneous, or some data, the sensor was not able to read the state properly. So you've spent billions of dollars to launch something into space, and there is a possibility of minute bugs creeping in, and that causes your entire system, $1 billion equipment, to fail. So you need to be able to trace the solution, trace the problem. Then finally you propose fixes, right? You propose, short-term fix, quick fix. You can call it quick fix, you can call it interim fix, you can call it stopgap arrangement. You can say, uh, let me try and fix this issue for the moment, and let me then try to work on permanent fix. So in either case, you have to do some sort of a risk analysis before implementing these solutions, right? What other modules can it affect? Are there any state flags that I set in my code that affects any other module? So this is the overall gist of root cause analysis. This is very, very critical for embedded engineers because you will be plagued with a lot of problems in the development phase. This is slightly modified, and is modified, and it undergoes a change when you enter a multinational corporation, right? So here, the way that you handle a problem is at a larger, different scale, and I want to present to you something called as the 8D problem solving technique. So this is like a process flow that big companies tend to follow, and I thought it would be interesting for all of you to know this. So when there is an issue or a problem, first we try and identify the stakeholders, which teams are involved, and this is where system level thinking is very important. So you have an overall view of the system that has the problem, right? Then you define the problem. You define what is the scope and impact of the problem. What devices is it affecting? What is the scale of this problem? How many of such devices are out on the market, or what is the impact? Then, does it impact only your company? Does it impact your vendors, your customers? What is the interim fix? Is there a quick solution that we can quickly implement to solve the problem at hand? Then we do root cause analysis. We try and pinpoint the exact cause of the problem. Then we propose a permanent fix. We implement and validate the permanent fix that we've proposed. Then we do something called as a defect tracking. Every company has different word for this, but I remember when we were in Infineon, it was called Cypress defect tracking system. And all of the key learnings from such problems would be documented, so that device design engineers could, or IC device engineers could keep this in mind when they make the next iteration, and that's how the process improves your product. And then finally, you recognize basically a handoff of all the other cross-functional teams that you involved, right? So one example that I can give you is, many years ago, there was a huge security flaw. This affected Samsung and iPhones, basically because the Bluetooth module was vulnerable, and the Bluetooth module that was used was from Cyprus. And a research institute in Sweden or Germany, if I'm not wrong, they were able to identify this issue. And it's a very unique problem. During the die manufacturing, there is some entropy introduced into every IC. So, at an atomic level, things happen, things change, and there is some noise within each IC. It's unique to every IC. And And how they used this particular noise within the microcontroller was that they used this noise in order to generate in order to give probably take an input take that as an input argument into a random noise generator. So these are called hardware random noise generators. So the uniqueness of every IC or a microcontroller that has these kind of properties, they use this to their advantage in order to generate hardware random noise, and that is used by Bluetooth modules in order to come up with some kind of encryption to connect one device to another device. It is so fascinating. And they found that uh, it was not truly random. It was a possibility that when you subjected the ice, because the manufacturing was so good, they found that when you subject the device to certain conditions, there is some sort of a possibility where it is not truly random, and you're able to generate and hack into another device. And when you bring a Bluetooth device to another Bluetooth device, you will be able to transfer the files, and the security is compromised. So this was a huge issue because it affected millions of devices. So when this issue was brought out, so you can actually follow RSA conferences where they bring to public light such kind of incidences, and which were fixed, of course. So Cyprus got together the team, device characterization teams, IC manufacturing team, design team, field application engineers, all the different stakeholders were identified to try and assess the problem. Then they saw what impact that it had. They tried to come up with an interim fix. They tried to identify the root cause for this issue. Then the interim fix was to handle it in software. Basically, you implement some sort of another over the layer encryption and send it out as a software update to all of these devices, and so that will help at least address the security concern momentarily. But the permanent fix was to make changes in the manufacturing process, right? So you identify this, then sometimes such changes may be difficult to immediately implement and validate, but you at least have a permanent fix, and that is what is needed, that you have eliminated this risk in the future. Then you document this, you prescribe the preventive actions that everybody needs to take, and then you finally congratulate and hand off and all the teams and disperse the teams. So this is how it's done for large scale problems. All right. So again, I would say thank you for all of your patience, for listening to me. And I just have a few more slides to go through, so kindly bear with me. I feel that it's important that we as embedded engineers inculcate a sense of system level thinking, and that brings me to my next topic. So what is system level thinking? Right now, as an embedded engineer, you are at the low level. So kindly bear with the pun, but you are at low level, and you are only concerned with what happens in and around you. You do not know what is happening on a larger scale. You don't know what's happening overall. So system level thinking is very important because it gives you a bird's eye view of the system architecture. You will be able to develop a holistic perspective of interconnected subsystems or components. So towards the left, I just have an example, okay, of a propulsion system that is used in spacecraft and satellite. So don't worry about the terms that you see there, but you just know that how things are abstracted and interconnected, so that if there was an issue in the propulsion system, you know where to go and look for, and you know what system it's affecting. So that's what system level thinking does, right? It gives you an idea of interconnected subsystems and components, and it's very useful to understand what are the component interactions, like how you see here. Because they can have cascading effect. So it reveals the feedback loops, right? From how you see, there are some feedback loops, there are parts that can cause delays. And if there is a delay in data or a delay in a control. So you might issue some PWM signal to your motor controller thinking the vehicle is moving, but in actuality you'll just be stuck in a place. But you've already issued the command to move, but you haven't moved. So you will try to see then how the system reacts, and it's a closed loop system, and that's where your understanding of control theory, knits into all of this. So you optimize. It helps you optimize the design. System level also, system level perspective also helps you add or remove redundancy. So you can see, you can say, okay, if this module fails, then I have a backup module. Or if there is no backup module, then you can say, let me introduce a backup module because it's safety critical. So finally, it helps you come up with safety critical decisions and operating policies. So let me give you a very crude example. If you remember a while back, I showed you the two-wheel balancing robot, right? So let us try and see, let us try and design a system where you have a two-wheel balancing robot, but with induction motors. So if you were to architect this simple system, you would say, okay, fine, I have my battery module, I need an IMU for my orientation, and I need to know at what speed I'm moving, so I have my accelerometer. I need to have a DC-DC converter because I need to step down the voltage for other modules. You have rotary encoders to kind of give you feedback of the speed of the wheel that is coupled mechanically. You have your motor controller that kind of controls the induction motors that you have, and your main MCU is where all of your computational logic lies, and then you have a charger to kind of charge this battery pack. So you have this entire system, you have the entire architecture for this system, but you are an embedded engineer who's working on the motor controller algorithm. There are different motor control schemes and algorithms, trapezoidal, sinusoidal. So you have implemented something, but you are the embedded engineer who was assigned with the task to kind of code that. So from a system level view, if you zoom in to the motor controller, this is what you would see. Again, abstract. We abstract it. So you have a motor controller board which houses an onboard microcontroller. You have some power converters and gate drivers that kind of control the motor, and you have optional sensory input that comes into the microcontroller for censored vectored control of your motors, right? So again, we've abstracted it. And then if you further zoom in to the level where embedded engineers work, it's this. We are concerned about this. We are concerned about how many ADC channels to configure. How do we control the gate driver? How do we, how do we generate complementary PWMs in order to ensure, can we have a sensorless control of the motor? Do we have feedback? Do we have position feedback from hall sensors? Do we configure those? Do we have current sensing? So what debug interface? What is the baud rate that I need to configure? What is the algorithm that I need to implement in this microcontroller, trapezoidal or sinusoidal? So you as an embedded engineer are always at this level. So you think about this, but you don't have an idea of how it fits into the system. And if you do not have an idea of how everything fits into the system, then it becomes difficult for you to solve a problem. So from here, you have to go back to the system level architecture where everything fits in. So when when there is a field issue and the motor was not able to run, or it erroneously ran at a different speed, then you can track back. You can say, okay, motor controller is interfaced with microcontroller. Did the microcontroller have microcontroller has some kind of a control logic that issues a command, right? It says when to start, when it tells your motor controller when to start and what speed it should, the motor should run at. So it is issuing a command. So did something go wrong there, or was everything correct and the data logging through Wi-Fi was where something went wrong? Where the correct was the communication interface broken? Why was it erroneous? What is causing it? Or did a command through the Wi-Fi cause some sort of a, the other way around? Did a command through the Wi-Fi that you issued caused some sort of a breaking of code here that gave wrong command input to the motor controller? So this is how system level thinking actually helps you uh, appreciate uh, uh, where you need to look into for solving problems. Um, I'm sorry, Kavya. I don't know whether I'm taking up too much time. I'll try to rush through the remaining quickly, but I thank everybody who's in this journey with me.
Yeah, no problem. Sure, take your time.
Thank you for the confirmation. I hope all of you uh, have the same feeling. All right, so let me rush through the remaining slides. I want to talk to you about the last topic on the agenda that I have for today, and that is how to thrive in a tech ecosystem, right? So, in order for you to be able to thrive in this ecosystem, you need to first develop a mindset. You need to be a tech enthusiast. And this doesn't come naturally. That is something that you need to work on. You don't resist change, right? Everything that resists change will be obliterated in the end. So the first set of factory workers who kind of objected to industrialization, since they did not brush up their skills on how to use the equipment, they were phased out. So don't take that as an example. Try to embrace opposing views. Try to understand where you need to improve on. Focus on learning and acquiring skills. Improve on your people skills. It's very important, and pay close attention to demeanor, your etiquette, and your ethics. So I would say I have a lot of examples to give, but because we are running short of time, I would skip it. They are all interesting stories. Maybe we can some of the students can get in touch with me later and they want to have a casual chat. Some of the best practices that I have come across is learn how to Google. You need to know how to Google for an answer. You need to search because you cannot solve everything on your own. Always under promise and over deliver. It has kind of helped me over a period of time. Be consistent and perseverant. Focus on small improvements each day. This will actually help you get things done a lot faster and makes you consistent with things. Learn to describe and define using technical terms. As I said, if you're able to define a problem technically, you've already solved 70% of it. Take every criticism as constructive one. Don't take it personally. They might be because people are very passionate about their domain. There might be times where it might come across as a personal attack on you, but take every criticism constructively. Always reach out to help for help only after you've done your groundwork and research. This is very true because in the beginning of everybody's career, it's a general tendency to just ping the other colleague and say, "Hey, can you help me? I'm stuck. I'm stuck." No, I would suggest do your groundwork. If you're going to for somebody to help you solve a problem, then you need to do your groundwork. Did you what have you configured? Did you do all of your configurations correctly? What did you observe? What is the problem that you are having at hand? Go to them with all of your groundwork and research so that they might be able to help you faster. And short-term and long-term goals. This is a very commonly asked interview question, but really we need to think about this because it helps you decide and take career decisions. Approach every task as a beginner and ask as many questions as you can. This again comes as a part of critical thinking that you need to develop. So above all, I cannot emphasize this more, but always try to become a better engineer. That is your life's goal. It should be your life's goal. And do not introduce yourself in any interview as myself. This is something that really annoys me and annoys most of the people who interview. If you were to say, if you were to introduce yourself, the interviewer already has your resume. He knows your name. So you can directly start off with where you're from and what are your qualifications and what are your skill sets, rather than to say myself Nagraj. Please do not do it. Learn to introduce yourself in interviews. I want to really thank Mubin sir, Maas sir, and Jaikumar sir. They've been instrumental, and I think everybody else can also agree to me. Those who are in Emertxe can agree to this. Thank you for. I mean, I'm really grateful for them for being such an inspiration to me. And so I leave you with the final question: are you ready to start your embedded career? Thank you. I apologize for torturing all of you for such a long time, but I hope it was beneficial.
Thank you,
So,
Pranith. That was a beautiful presentation from you. And I would also like to inform you that ample number of students have also told, take your time, sir. It's very informative.
oh, thank you so much.
And I have 2, 3 questions from our audience. So the first one would be how to effectively stay updated on new technologies while juggling around busy work schedule. And what strategies do you use to learn about emerging microcontroller architecture and protocols in embedded domain?
Okay, so this is a twofold question. Let me answer the first part.
Sure.
The first part is is an easy fix, right? How do you stay updated? How do you know what is happening? It's very simple. Turn off your Instagram. Subscribe to only
Mhm.
tech channels on YouTube, and
Mhm.
that kind of solves the problem, because we are creatures of habit, and if you try to deviate your mind from the goal that you have, and we have enough sufficient distractions in life. We have so many issues and problems to deal with in our personal lives, in our family, and then you have a busy work schedule. But in the midst of all of these things, try and focus on this and feed your mind uh, you know videos, and follow people on YouTube. I i generally tend to follow some German engineers who are into aerospace, who are working on drones, and some concept. For example, I can just give the name. I always like Integza.
Mhm.
I like Brandon Staton, who works on planes. It's not related to embedded, but that keeps me motivated. And Boston Dynamics. Have a look at their videos. Try and see what they're doing. SpaceX. Follow news. So orient yourself to a tech enthusiast mindset. So that kind of automatically starts piecing together information that you find, and you know what technology is in demand. So that's the first part of the question. The second part of the question is, when you have a industry, you want to know what protocols are there. So I would say, rather than focusing on uh, a lot of things, focus on the quintessential things. I squared C and SPI they might never go out until ML comes.
Mhm.
So ML might come, it might write another layer, it might kind of suggest a different protocol or an interface to be used, but that is later on during the line. But even if it does, the world is already operating with billions and trillions of ICs which have already implemented I squared C and
Hmm.
SPI. So focus on the quintessential things, protocols and interfaces. You will come across them in your career. For example, I came across something called serial memory interface when you have hyperflash memories. So that is something that you'll come across on a need to know basis. But is it used everywhere? I don't think so. So was it beneficial for you to actually getting to know in depth what SMIF is?
Yes,
So
yes.
I would say, yeah. So focus on the essential things first. All of these things
Mhm.
come later on.
Okay, so there's one more interesting question. As an employee in embedded systems domain, does one suffer from imposter syndrome? Because there are a lot of technologies to learn and remember, and sometimes the employee might feel incompetent. How does one tackle this?
Very true, very true. Yeah. So what happens is, uh, you are exposed to so many new different technologies. You cannot literally keep up with all of them, and that's why it makes sense to be a jack of all trades. I don't know whether most of you have even attempted writing IELTS. Okay, I'm just giving you an alternate analogy to explain my thought process. So you have a speaking session in IELTS. So you'll be given a random topic to speak about, and you need to speak continuously about it for let's say a minute and a half or 2 minutes. And how do you generate thoughts? It might be a topic that you have never come across. Now, if I would suddenly stop you in your tracks and I would interview you about, let's say, some economy, or I'll come and ask you saying that is littering, how do you tackle, what solutions do you propose to tackle littering in your city? And why do you think littering is high? So some question which is out of your scope, so what do you do in order to be able to answer those questions? You need to have a thought process. Your mind generates answers and questions based on the things that you've exposed your mind to. So try and abstract concepts. Just try and come across terminologies, come across different technologies. Don't go in depth until it's necessary, but at least be aware. So this awareness kind of would help you try and have grasp over a lot of things in the industry. You'll know what is happening on ground, on the field, while not being left out.
Thank you, Pranith. Thank you for answering these questions. And there's one more question. Please send the recorded session of this webinar. Yes, definitely our team will be sending out the recorded sessions, and also the presentation given by Pranith would be mailed to you guys. And Pranith, could you please stop sharing your screen so that I could share the screen and announce the quiz?
Sure, let me try that. Has it stopped?
Yes, Pranith, thank you.
Right.
So guys, the most awaited part of the webinar, the quiz. And don't worry guys, all the details will be mailed to you. The quiz form will be mailed to you, but please make note of the quiz code. If the quiz code is invalid as informed in the earlier beginning of the session, we won't be evaluating your answers. So please take a note of the quiz code, and form definitely will be sending out mails after this webinar. And this is the Telegram community that we have created for our masterclass webinar. Stay in touch with us to our Telegram community so that whenever we are coming up with the next masterclass webinar, you guys will be notified regarding the same. And also please take a screenshot of this stamp. We'll also be mailing you these stamps so that the person who collects more number of stamps will also be awarded with some goodies. And coming to our social media, guys, please follow us on our social media so that you will be getting all the updates to Emertxe. This is the link, QR code for LinkedIn and Instagram. I'll give you guys 2 seconds so that you guys can scan the QR code. And for the guys who have joined through your phone, please take a screenshot of these QR codes so that you can join our social media cult and receive all the updates that we post on our social media. And we have Mubin sir on the call, a technical head. He would like to give a thank you note to all of you. Over to you, sir.
Yeah, thanks, Kavya. Hope I'm audible.
Yes, sir.
Yeah. So it's been a basically a great evening today. So we have one of our alumni, Mr. Pranith, who has completed a course long back. So pleasure to have you, Pranith, present to our audience about your basically journey with Emertxe, as well as how you basically build a career by working on different companies. So this 2.5 hours of session, I hope all of our basically audience had a great learning basically outcome as well as takeaway. So thanks, Pranith, for this wonderful webinar. And also I would like to thank all our attendees who participated in this webinar. So as Kavya mentioned, we do have these webinars coming up very often. Maybe in a month or in a month's time, we'll have another webinar lined up. So you can subscribe to our basically social media channels so that you can be aware of these webinars. So once again, thanks Pranith for this wonderful session. So it's been basically a great evening today. And if you have further questions, you can reach out to basically our team. Maybe we can direct these questions to Pranith again so that we can get the answers to it. Over to Kavya.
Thank you, guys. Thank you. Though the webinar was extended by the information which was passed by Pranith, I see still almost around 150 people are engaging in this webinar on a Saturday busy evening for you guys. So I would like to thank you guys once again. And our team will shortly be mailing you the Google form link. And I hope you all would have made a note of the quiz code. Thank you, guys. Have a great weekend ahead. Bye-bye. And thanks once again, Pranith, for the wonderful presentation given by you.
Thank you, Kavya, for facilitating this. And yeah, thank you, Mubin sir, for providing this opportunity to reach out to so many students. And thank you all for joining. Sorry for the sorry for the long lecture, but I hope it was beneficial for all of you. Thank you.
It was obviously beneficial for every one of us here, Pranith. Thank you, guys.